So open power db and we'll uh, connect the laptop with power db and kit will be connected, and then we'll enable the power supply to switch on the relay, and then we'll inject the current to test the differential protection with the settings that we entered in the relay, and check the smrt tab, update the port here, connect OK. This rtms software will open, so just wait and let it open. It's asking me to update the firmware, but right now I'll not execute it, I'll cancel. Now we'll go to this settings tab and we'll enable this supply voltage here for the auxiliary supply. So first check in the device. So this device is 110 to 250 volt AC, so we can select any voltage range between that. So I'll go with 125 and enable it. So once you enable, you can see a voltage icon here with same voltage that you entered. So just press it, so it will supply the power to the device and device will boot. Once you get the healthy status on the device, that means device is powered up completely. So now just you can first check the current and voltage injection. So for that we need to convert the channels. So here go to hardware, the settings, and select all the 6 current channels, enable it. So you can see all the channels here will turn yellow. So now you can inject some minor current to just check your connection whether you are connected perfectly. Inject 0.1 ampere on all, enable it, and inject only on the HV side R phase. So I only injected 0.1 ampere on the HV side of R phase. So here you can see that 200 is my CT ratio, so I have injected 10%, so I am getting 20 amperes. On other phases the current is 0. So similarly you can check for the other side also, LV side. So 10% will be your 105 amperes. So you can check here, same current I am getting. So that's it. So that way you can check for all the channels. Now you can disable it. Now we have to test the differential protection. So go into this new test tab. In that, in the 3-phase differential, we have a template ready. So just select it, and you can see that the transformer representation is coming with all the CT, VT, differential settings detail. So enter here 66 kV on the HV side, and CT ratio is 200/1 and MVA is 20. This is 11 kV bar 1200/1 CT ratio. So select it, and vector group is DYN11. So just choose DYN11 and that's it. So it will automatically enable the zero sequence filtration. Now for settings, you don't need to set it manually. Just go on to this bookmark icon and select the P64 template. So you will get what you see in the relay itself. So now IS1 in our relay we have entered as 0.2, the pickup value. First slope is 30%, so change it to 30%. Cut point is 2. Then K2 is 80%. Then high set is 5. This is 13. Second harmonic blocking and fifth harmonic blocking is 35. Choose these values, select, and you can see the settings has already been updated in the device. Now check OK, and you can see all the test tabs will appear here. So first of all we need to do the stabilization test. So select the stabilization test. So you'll see this window. In this you can see that the currents on the HV and LV side, winding 1 and winding 2, are injected based on the 1 PU criteria of the device, that is 20 MVA, 175 is 1P 166 kV side and 1050 on the LV side. So you can check here that 175 and 1050, and since it is a DY11 transformer, so there is a vector shift of 180 plus 30 degrees, but as the device here is, I think, not configured correctly, that's why it's showing 150. Otherwise you will see here 210, which is the correct value for D111. So now you can see it's 210, so the angle shift is 0 and 210. So now we'll just enable it, and once you enable it, you can see in the device HMI, in the measurement 3 tab, the differential current on phase A, B, C is almost 0, but the biasing current is almost 1 pu. So this is what we are testing here, the stability criteria. So if you get any differential current, that means your stability is not true and you need to check your configuration or setting or whatever, or maybe the test kit injection, what you are doing. So once you finish it, since it not received any trip command from the device RL1 output, and as soon as I will close it, it will give you stabilization test passed, because there was no tripping. Now we can check the timing. In this kit will inject some differential current, and based on the output it will just check the trip output. So we can check this for all. So you can see that LED 1 is glowing continuously and kit is injecting, and the timing has been recorded as almost 30 ms, less than 30 ms for all the conditions. Similarly, there is pickup test. In this the kit slowly injects some current, and it expects some pickup value, means 20% value. So once the device reaches that 20% value, so 175 is that 0.2 is the 20% value. So kit will inject the current slowly and it will increase the differential current, and as soon as it will reach 0.2, it will expect some tripping. So it took place exactly at 0.2. So this is a pass indication, so that's why we're getting a green check. Now if you are doing a single phase testing, in that case you need to check that there are some multipliers which you need to put in the settings tab itself, otherwise the test will fail. Now this is the characteristic, the 3 section slope of differential, very famous. So for this we can check in the flatter zone, we'll inject one test case. In the K1 section we'll inject one, and in K2 we'll inject another. So in this again relay will slowly increase the differential current, and it will check whether your tripping is taking place exactly on this line or it is exceeding or not. So if it is exactly nearby about your tolerance, that is 10%, so you will get a green tick mark, so that means your test case has been passed. If you want to further narrow down the boundary, so you can change the threshold value to 2.5% as per IEC. So now you can see the first case is passed, only 1% error is there. Now again it's in threshold, within the threshold, so but still we have not received trip, so we are waiting for it. So now this is again no zero in slope number 1 K1 section. Now we are checking the K2 section. So normally this K1 section is for your OLTC and minor internal faults, and K2 section is for your true faults and heavy in zone faults. So we take care that there is, even if there is any CT saturation, we should not trip. So you can see all the test cases have been passed. So again there is a second harmonic testing. In this what it do, basically it injects some current, and it's a mix of second harmonic and your primary value, and it will expect trip, but I think we need to check it. Then you can check the short characteristics. In this you need to add shorts in your restraint zone and trip zone, and for restraint zone the relay should trip, and for not trip, and for trip zone it should trip. So you can check here again. So here no tripping, so it's passed. The other shot is in trip zone, so trip. So on all the restraint zone we not received any trip, and all the trip zone we received trip. So this is the basic differential testing.